going to look at this question. A particle of mass 0.8 kilograms is held at rest on a rough plane. The particle is inclined at 30 degrees to the horizontal, and the particle is released from rest and slides down a line of greatest slope on that plane. The particle moves 2.7 meters during the first 3 seconds of its motion. We are required to find the acceleration of the particle and the coefficient of friction between the particle and the plane. Okay, we draw the diagram. This is the particle. This is the inclined plane at 30 degrees to the horizontal. And then we need to put in the mass. The mass of the particle is always vertical. And since the mass is 0.8 kilograms, we shall convert this to weight so that we multiply by g, the acceleration due to gravity, so that we get the weight in newtons. Now, since they want the acceleration, we know that it was released, so the initial velocity is 0. It had covered a distance of 2.7 meters, and it did this in a time of 3 seconds. So using the equations of motion, the appropriate equation we can use here is S equals to ut plus a half at squared. So substituting these values in, we shall find that our S, which is 2.7 is equal to u being 0, it will convert everything here to be 0, so I ignore this and use a half times the a which we are looking for, and then times 3 squared is 9. So to make a the subject, I have a as 2.7 multiplied by 2 divided by 9. This will be the value in meters per second squared. That is the acceleration that they want in part 1. Now part 2 wants us to find the coefficient of friction between the particle and the plane. Now we shall have the normal reaction at this point. The normal reaction is perpendicular to the direction, to the plane. So you need to make sure that this angle is 90 degrees. So this one is the normal reaction. I can put R. And then this is the coefficient of the weight perpendicular to the plane. I'm going to explain how we are going to get that. Then also the weight has a component along the plane. It should also be represented by dotted lines in this direction. Now, this angle is 90 degrees because this is a right angle triangle. This makes this angle to be 60 degrees, meaning that this angle would be 30 degrees. Now, I'm going to draw a line perpendicular to the plane. This line should be parallel to this one, so that I have this angle is 90 degrees, and it is going to help me find this component and this component. Using this triangle here, this acts as my hypotenuse, and this acts as the adjacent, because adjacent to 30 degrees. So if I'm to use SOHCAHTOA, we find that if maybe this is x, I can call it x, and this is y, I can see that x over 0.8g, which is the hypotenuse, becomes the cosine of 30 degrees. In other words, we are using cosine being this is h. Cosine being adjacent divided by the hypotenuse. The adjacent is x, the hypotenuse is 0.8, and it gives me cos 30, making x become 0.8g cos of 30 degrees. Similarly, y now represents the opposite, because y is opposite to the angle 30. So opposite divided by the hypotenuse gives me sine. So I will say y over 0.8g is equal to sine of 30. So So that means my y will be 0.8 g sine of 30 degrees. And so this value is going to be the component of the weight in this direction, which is 0.8 g cosine of cos 30 degrees, while this one is 0.8 g sine of 30 degrees. Now, since the particle is moving down the plane, the frictional force should be opposing the motion of the plane, the motion of the particle, and so this is how I represent the frictional force. And the only force acting on this particle is this. So we need to get the resultant force of the two. The resultant force would be would be 0.8 g sine 30 minus F, because this is the force pulling and this is the force opposing. So since the particle is moving downwards, the resultant force will be this. Now we know that resultant force is equal to the mass times the acceleration. That means my resultant force, which is 0.8 g sine of 30 degrees minus F, should give me the mass 0.8 in kilograms multiplied by the acceleration, which is the acceleration we had got the other time, the 2.7 times 2 divided by 9. So from here, it means I can be able to find the value of F. Once I get the value of F, I will use F equals to mu r, whereby our r is equal to, no, we want mu would be F divided by r. I have obtained the value of F from this expression. After getting the value of F from this expression, I substitute in this formula. Mu stands for the coefficient of friction, and R is obtained from this diagram, whereby the normal reaction is equal to this. In other words, R is obtained by saying it is equal to 0.8 g cos of 30. Now, obtaining the value of R, then obtaining the value of F from this expression, substituting this formula to obtain the coefficient of friction between the particle and the plane.
Okay.